Hello friends, welcome back to the Yitzy Guitar YouTube channel. So we're back here with the 1961 Fender Super. Just one of the coolest amps I've ever had the pleasure of working on. We've done a ton of stuff to it already, so be sure to check the link in the description if you haven't already watched the previous videos. We stuffed all of the caps with new Sprague Adams. We did the doghouse, yada yada, resistor here and there. But it looks basically all original. Really happy with how it came out. So there's just a few more things we need to do, really. First being, I want to check these astrons here for leakiness. So to do so, we have to lift them up, and then we will use a 1 meg to ground. It's a trick that Lyle from Psionic Audio taught me. So we will be lifting these two and testing those. The rest, honestly, tested basically fine. Nothing even close to a volt, other than one cap, which I don't know if I showed on camera or not last episode, but it was this cap right here, this astron going to the presence control. This one's leaking 12 volts, so that one's unfortunately got to go. But of all the ones to go, that's the most hidden, not a huge deal. And we do actually have a blue molded that we can swap in there that is the same value that the owner provided, so we're good to go. Now, hopefully these ones are okay. If they're not, then yeah, we will likely go blue molded here as well. And then what I'm possibly going to try and do is see if I can figure out how to stuff these dang astrons, because I think the look is really cool, and it'd be really nice to be able to stuff them with a more modern cap and still retain the original shell. So we might try that this video, or maybe it's just gonna be a total fail and I won't include it, so you'll know if it's in the video or not. But either way, let's just go ahead and we will desolder these two connections, lift these two up, and we will check with the setup. So let's go ahead and get to it. All right, so I went ahead and reinstalled the blue moldeds we just tested. And before doing that, I removed all the solder from the 4 eyelets. I cleaned them out, and then I used isopropyl to really clean them out. And then reinstalled, obviously, with fresh solder. So I'll let you take a look at that. So 1, 2, and then these two in the middle here, 3, 4. So all of that looks really good to me. And then I did hit a couple other joints that looked a little suspect, like this one right here. And maybe 1 or 2 other ones that I noticed. I just want to double check. But everything else looks good to me, honestly. So next up, I think we'll go ahead and remove this astron from the presence control and swap a blue molded in there. Okay, we've got the old astron out here. It's a 0.1 200 volt. And then we've got the replacement blue molded. This is a 0.1 200 volt as well. You can see they're roughly the same size. And this one must have been a new old stock, because it has got crazy long leads. I've never seen a cap with leads this long before, especially this size. So that's kind of cool. It's going to need very little to actually do this, but it should fit perfectly up there in the corner. So we'll go ahead and get that prepped. We did have to bring out the big iron to take care of that solder joint here on the brass plate. So I do have that warming up off camera. But yeah, we'll just go ahead and kind of get this placed, and we'll cut the lead once we have it in the right spot. All right, that looks pretty good. So we can go ahead and snip that and take care of these two connections, and we're good to go. All righty, let's go ahead and take a look at that. Hopefully you guys can see that okay. It looks good to me. So we and already checked it to off camera. I just used alligator clips just to confirm it is not leaking, and the blue molded is not leaking at all, as you'd expect. So we should be good to go. We are getting very close. Next stop, I think we'll go ahead and take care of the bias. So if you guys remember from the last episode, it was biased quite cool with the stock resistor. So let's go ahead and figure out what value resistor we need. And then I haven't totally decided if I want to go just resistor or adjustable bias. So let's just go ahead and find the value that's perfect first and foremost. All right, next on the agenda is to go ahead and get the bias dialed in. So what I've got here is a little resistance box. And this lets me set a custom resistor value here without having to swap a bunch of resistors in and out. I've never used this before. So I'm looking forward to giving it a shot. It should be perfect for this, to try and find the exact value resistor we want. And then from there, we can decide if we want to add a adjustable bias, or if we want to keep it looking completely factory and just swap the resistor to be right where we need it. So let's first go ahead. I've already tested it off camera just to make sure everything seemed to be working okay, and it does. It all checked out. So we're going to go ahead and remove this other end of the, was it 43K? Was it yellow, orange? Yeah, 43K. So we'll go ahead and remove that, this end, and then we will just kind of patch in this box here and dial in the exact number. I'm going to guess, let's see, what should I guess? I'm going to guess we probably need to be in the, oh gosh, maybe 27K, I think is going to be my guess. So let's see if that's roughly where we need to be. Let's go ahead and just remove this end first. So that'll basically just be serving as the leg of the resistor, and then this is the other leg of the resistor here going to ground. You can just probably barely see it there. So now we're going to go ahead and test it with the amplifier on and the bias resistor being this resistor box here. So I've got it set to 35K, and it seems like we're getting under that, so about 32K. So we'll just keep that in mind as we go. We'll go ahead and switch this over to DC volts so we can see what the negative bias is. Before, we were running, I believe it was the kind of low negative 60 volt range, whereas the schematic calls for negative 55. However, it's got a completely different bias board, so I'm not surprised that's off. The numbers we had before, I'll show real quick. The left tube socket, which is what the bias probe is connected to right now, had 485 for plate voltage, and then plate current was 12, and that resulted in a 25% dissipation, which is quite cool. So we've got a lot of headroom to move. So let's just go ahead and prep here. We'll grab the right tubes, 5881s. All right, so we got the right tubes. I'm guessing the plate voltage is going to be in this 450 range. We'll kind of set it there for now. And we'll go ahead and flip her on. So confirmed, we are getting negative bias. That is fine. Negative 50 range. Again, the schematic calls for negative 55. So everything's looking good so far. Let it warm up for a second. And we are at roughly 32K for the resistor. So it's pretty close, 459 volts. And then the plate current is 32. So that gets us at 63.9. So just about right on the money, actually. That's pretty good. So I bet somewhere in the 34K on this, which is probably going to result in a 33K, I would say, resistor. Is going to be pretty close. So let's see what that gives us. 455 volts, plate current 36. This is 70%, so that's quite good. I think I would rather it be a bit cooler though. So let's go ahead and see what the resistor value is actually for this. So we got to turn it off so we have no voltage first. So let me see what resistors I have in stock. So the plan is pretty simple now. I've got this 22K, which was a pull from another vintage Fender. And then I have this Pyre. This is a 25K pot. So these together give me enough range to be able to get us roughly where we need to be, which is, you know, in the low 30s, low 30K range. So obviously 25K. And then a 22K, that gives us a pretty wide range, including that, and basically exactly center on this pot with these two together gives me right where I want to be in the 60% range. So this gives me plenty of latitude either way, but I just really like that it landed right in the center more or less. So we're going to go ahead and basically connect this to one leg here, and then the other leg will go here. So it'll look like this. And then the wiper will go to ground here. And there's a few different ways you can do it. Sometimes I do it this way. This is more, I guess, technically accurate to what Fender did historically, where the pot is kind of the, I guess, the last in chain or first in chain, I guess, depending on how you look at it. But to feed the system, it is the last in chain from ground to feed the system, or for, again, it doesn't matter, but you guys understand what I'm trying to say here. This way is more Fender correct, you know, where they'll have a pot right here, like a full-size pot you'll see in a Blackface Deluxe Reverb or something. However, it's, I guess, technically not as safe, because if you have it that way and the pot fails, you got your resistor, and maybe the resistor is typically grounded to the pot. If the pot fails, then you're going to have an issue where there is no resistance on the bias, and so you're going to get a runaway bias essentially. Whereas if you do it the other way, this resistor will kind of serve to be the, I guess, minimum resistance if the pot were to fail. So this is kind of the better, safer way to do it. And I also like that it's more out of the way, so it's kind of less noticeable, as we're trying to be a bit discreet with this. So that's the plan. We'll just go ahead and first get the wiper installed into this eyelet, and then from there we can kind of figure out everything else. So that's about as compact as I can possibly get it. All right, let me see what that looks like from the top. So basically we would cut that and trim this resistor, obviously, but it would be more or less like that. So the alternative option is to do the more, I guess, quote unquote, traditional Fender way and have this right here, which I've done before, but the only trouble with that is you've got a very narrow area between the bolt here and this bolt. And yep, the actual size it's just a bit too big. You wouldn't be able to get this out or this one out. So that's not going to work either. So it's got to be over here. All right, let's go ahead and move forward with that. Let me get it all done, and then I'll try and talk to the owner in the morning and see what his thoughts are, whether he would prefer to keep the adjustable bias or have me source a new old stock 33K resistor to replace the original. So let me get a different one that doesn't have a little damage on it, and let's go and do that now. And just like that, we should have adjustable bias. So let's go ahead and confirm with the multimeter here what range we're getting. So in theory, this should put us right, so right around where we were, which is around 31K. So hotter bias will be going this way. Cooler bias will be going this way. So this gets us pretty close to the stock value, which is quite cool. And then somewhere around the middle, right around there, should give us between basically 65% is what I would guess this would give us. So that looks pretty good. And let's go ahead and get some tubes back in it, fire it up, and confirm we are getting what we're supposed to. And then, we're in a good spot. All right, so we are all done. As you can see, the adjustable bias setup is working perfectly. We're at 460 volts plate voltage and around 32, 33 plate current. We put that into the Robinette calculator, and that gives us 66% plate dissipation for 5881s, which is perfect. So really happy with that. If we go turn the potentiometer all the way to the left here, my left at least, this will give us basically the same amount we were getting from the stock resistor, which was biasing it at around 20%, so very cool. So around negative 61 volts. So as we decrease the resistance, we will get a hotter bias, and right around noon gives us 460.33 and around negative 50 volts from, or negative 50 volts for the bias voltage, and that's right on the money of where we want to be. So it works out perfectly on the pot. Very easy to remember for the owner. And we're good. Now, I want to first and foremost acknowledge the fact that it is not nearly as clean and perfect as far as, looking 100% original as everywhere else in the amplifier. But I don't have a new old stock 33K resistor that would be required for that. And adjustable bias, I think, is a really, really good mod. It's kind of the only mod I'm down to do to amps. And the owner asked me to do what I would do in my own amp. And honestly, that's what I would do. Now, we can also very easily, well, hopefully easily, try and find a new old stock AB resistor that is a 33K roughly, and swap that in. That's a very easy swap. So if the owner decides he wants to do that and he wants to order that part, that's totally fine by me. No harm, no foul. But this is what I would do in my own personal amp. So I will text him in the morning since it's pretty late, and we'll confirm. But yeah, it's rock solid. I'm really, really happy with how everything has come out. The last little bit we need to do is just clean all the pots, clean all the tube sockets, get any of the last little pops and crackles out that we can, and then we'll play it, let it burn in a little bit, and I guess send it off to the owner, which I will be sad to do, but I'm sure he's very excited to have this back up and running. So we'll go ahead and end tonight, and we'll pick it up hopefully tomorrow after work when I can play it a bit more and confirm she's all good to go. So we're back here just to do some final checks with the amplifier. I'm not exactly sure I'm going to edit this together, but I've been letting it run for a while, and it seems fine. I'm not noticing any pops or crackles or anything. It seems totally solid. So we did clean out all of the tube sockets another 2 or 3 times. So I'll just demonstrate moving the tubes around. No noises. This V5 is still giving me trouble. All the other ones are totally fine. So V5, it's still got the original tube in it. And I'll go ahead and swap that for a JJ real quick. And sorry for the motorcycle noise going by. But yeah, if I swap it for a JJ, it is a thicker tube, so it doesn't really make any noise, but it's still slightly microphonic there. And if I do this, you'll notice, hopefully the mic will pick it up. Listen to that one. No way the mic doesn't pick that up. So this is extremely microphonic, the cable itself. I don't think it's anything to do with the pins themselves, the tube sockets, or the tube, because I'll switch it over to the JJ and I'll show you. So we'll go standby, pop it out, swap in the new JJ. So the new JJ, I'll show it's just still microphonic. Really made no difference. Let's see what that wire goes to. That is pin 7, maybe? It's really hard to tell. Pin 7 on 12X7 is a grid. So that's going to the junction of the 1 megs and the cap here. So this one, these are all microphonic, actually. But this one is going right here. And I did re-hit that solder joint, so that's solid. I don't really know what that would be about. This one right here, that is going to, that's what pin? This pin 6. It's right here. This is pin, looks like pin 1. So pin 1 is going here. And then pin 6 right here. That is going, looks like it's going up here. So again, all solder joints were touched up. So at this point, to be honest, I'm not really sure of a solution to that apart from replacing the wire. I'm pretty sure it just has to do with the wire. Eventually they might get microphonic. And if I go over here, these aren't microphonic. Really, maybe a little bit, but nothing like this right here. So I guess the only other option would be to completely reflow the solder joints again and see if that fixes anything, but I don't believe it will. So I'm going to do some research, and then I'll talk to the owner and consult a couple people I know that might have an answer. By the time you see this video, we will have moved on. But either way, V5 is still giving me a little bit of trouble, but once I have a JJ in there, there's no noise or anything. It's not really microphonic, the tube. So yeah, to the owner, I would just recommend swapping this tube here with something other than the original. All the others seem to be working totally fine. Now, as far as the bias is concerned, we're at 454 plate voltage and 32 plate current. I don't know if you can, you can't see that. So there you go, 452, 453, and 32. So I pop that into the Robinette calculator. 450, was it 454, 33? It says 454, 32, 33. And that puts us right at 65% plate dissipation. You can see that. So that's basically perfect. Now the owner did provide multiple sets of power tubes, so we will swap in a different set and confirm whether we need to change the position of the adjustable bias pot here or not for the owner, so that he knows if he swaps them where to set it. You know, it's honestly a small difference, is not going to change anything. But yeah, and then all the other pots or all the pots have been cleaned and they're all seemed fine. So no problems there. There is a little bit on the volume controls actually. And I tried looking at this last night. I guess I can try and show it on camera real quick. There's about 0.015 volts on the pot. And it comes down to, so the volume control pot is connected here to the I think it's the treble pot. And then that one's got this white wire right here. And the white wire is connected to this cap right here, this little disc cap. And at that disc cap, so it's going to be a bit noisy when I touch it, you'll see we're getting 0.024 volts. Now, I did freshen up the solder on every single joint, as I said. So for this to have that there, it's just it's in the board. So if I kind of go to the board itself, you'll see there's some voltage here. Now I did already use some isopropyl in the area, but you can see there's just a little bit in the board, and that's honestly kind of unavoidable. You can see right next to the eyelet, we got 0.025. So I think what I'm going to do is just hit this with more isopropyl and maybe clean out the eyelet and try again. But it's never going to be perfect really unless you do some major work. So it is just kind of a little bit of once you get past 5 or 6, you get a little bit of scratch, but very, very minor. Same thing on this one. It's totally fine through here. And then just a little bit right here around 7 or 8. And same issue. So other than that, everything seems really solid. And yeah, I mean, I lifted and I showed in the video already kind of, the voltage on these. And, you can see it oscillating a little bit. I'm trying to think of which ones I showed on camera. I guess this one, for example. So it's showing 0.037 volts, but it's not. I took it out and tested it, and it tested completely fine. So it's really just in the board itself. You can see the board around it. It's got 0.01 volts or so. So it's just a little conductive, and that just kind of comes with the territory. With these old Fenders, there's really no getting around that. So other than that, we're, I think, in a really good spot, and I'm really pleased with how everything is coming about. So I think next steps, we'll just throw in the other power tubes, confirm the bias on those, and I think we're just about able to be on our merry way. Really, really excited with this. All right, so we've got the other set of power tubes that the owner provided, all vintage 5881s. And this set is currently biasing a bit hotter, so it's 454 for the plate voltage, which is pretty close to what it was before. And then the plate current is quite a bit higher, so we're up at 38. And that puts us at 75%. So we basically jumped up 10% in the bias from 65% to 75% just with changing the tubes. So this is a bit hotter than I would personally like. So just for the owner to see kind of, maybe a better range or a better setting, you can see the bias control there. So we would turn that to the left counterclockwise just a little bit. So I want to see the plate current closer to around, maybe 34 or so, 34, 33 range. So let's see what that gets us at. 458 from the wall, 458 plate to cathode voltage, and then the plate current now at 35. Let's see what that gets us at. That's at 69, so we'll go even lower than that with this set of tubes. Really, I'd say probably about there, 460, 32. That should be right on the money. We were getting that earlier. So just to show the exact number for that, 460, 32. And that's getting us at 64% plate dissipation. So basically exactly what we were with the other tubes. So again, just to show that the bias setting here For this set, for the new set of the kind of brown bottom RCAs, and then for the other set, the original set that came with the amplifier, we're closer to about there. So, you know, a fairly small difference makes a fairly big difference as far as the actual bias of the amplifier. But anywhere in kind of that range, you know, from say if noon is just straight in the middle of the range of the pot, if you were to go, you know, maybe 10 to 11 o'clock, you should be pretty safe. 10 to 11:30, I would say anywhere in that range should be pretty safe for the amplifier. So, and I don't hear any issues with them. They sound fine. I'll plug a guitar into it just to confirm it's safe and, you know, running okay, but it seems solid. I think we're in a really good spot. So I'm getting a little bit of voltage on the volume pot. You can see this is the leg of the treble control, which is connected to the volume pot. And we're getting 0.04 volts, which is plenty to give a little, very slight, so there's nothing on here, no scratchiness, but on the volume control, just past, you know, 7 or so, there's a little bit of scratches. Not much, it's very little, but it is there. And this white lead, which goes all the way over here, right here, and pops out according to the schematic right here with this little cap, we'll see we're getting that voltage right there. Now here's the thing. I've already touched up all these solder joints, all these eyelets. So if I go off of the eyelet just on the board next to it, look at this. So that's just the board being conductive, 0.03 volts or so, and that's after, you know, hitting it with the soldering iron. So same thing over here with this volume control. There's the same kind of little cap right here. If I go just on the board itself, we'll see that there's some voltage around it. Not nearly as much. We're getting, you know, 0.02 in this case on the eyelet itself, but we're still getting, you know, some voltage all around it. 0.013 right there. This is not touching the eyelet. So yeah, there's just some conductivity in the board. This is just kind of classic vintage Fender amp, right? There's really, to my knowledge, not a ton you can do about that other than what I've already done, which is hitting the eyelets with heat, clearing them out, you know, where possible and where necessary, and using isopropyl to try and pull out some of that. So if I just go to the board, you know, in a random spot, look at this, 0.02 volts, just this random spot right here. So we've already tested these astrons. They're all totally fine. It's the board itself that is actually conductive. So just kind of interesting and just, you know, I guess noteworthy. There's not, again, a ton I know of that we can do about that I haven't already done, but I think I'll just hit it all with some more isopropyl and without getting too crazy. It's, you know, it's a small amount. 0.02 volts is not a lot. It does just result in a little bit of, you know, just a little bit of kind of noise on the pot. Nothing major. The input jacks are all showing it a little bit as well. And so that's, just kind of frustrating, because if I follow this lead, it's this yellow one right here, and it goes to, I want to say one of these tone caps here. But yeah, if I just kind of go around the eyelets, there's voltage. So, it's not necessarily as bad as the 70s Fenders, where they have, some of that, the wax, which just makes it really terrible to work on. So these don't have that, but they still, the wax was to try and prevent this issue, actually. And neither work. No wax doesn't work, and having wax doesn't fix it either. But yeah, just kind of wanted to show this. All the caps test fine, but that doesn't mean you're in the clear. 0.02 volts all over the board. That 0.03 just in a random spot like that. Look at that. 0.03 here. There's nothing even around here. So, super fun. Okay, so we did multiple passes of isopropyl with the toothbrush, as well as naphtha, and then more isopropyl to kind of top it off. So, and then obviously using the heat gun as well. And I think that's about as good as we're going to be able to get this. So we did multiple passes. Really, the only perfect solution, I've said this before in other videos, is literally removing all of the components and treating the board itself separate of everything, and then reinstalling, which is obviously just not an option, especially on something like this. So I think we did about as good as we possibly can, and it just kind of is what it is with this thing. As mentioned before, I've already hit all the solder joints again. So, we've done basically all we can do. It's just kind of nature of these vintage Fenders. So we'll go ahead and turn it back on here and see if we fared any better this time around. But even if we didn't, I know it will be a little bit better. It has to after all of that. But I don't expect it to be perfect. But yeah, let's just go ahead and see what it is. So I'll let it dry, air dry for a little bit longer, and then we'll flip it on. All right, moment of truth. Let's see if it's any better. We'll go over here. Unbelievable. It's just as bad as it was before. Even worse in some spots. 0.047. I don't think we saw anything that high. 0.06. Wow. I mean, this area specifically, I hit the most with isopropyl and naphtha and the heat gun. So I really have no explanation for that. Very frustrating. Yeah, I'm really not sure. Let's see if it was any better over here. Yep, it seems like it got better there. Same thing. Okay, so it seemed like it might have gotten a little bit better in other places. 0.2 volts right here. Look at that. There's nothing even there. 0.1 volts. It seems like it got worse over here. Super microphonic wires. I did soak those in isopropyl as well. See if that would help. It obviously did not. I was expecting much better than that. And yeah, really don't know any other solution. So I guess we'll just end here. And it's seeming like every time I think I'm done with this project, there's something else. So I guess there'll probably be another video to this series. So let me know what you guys think in the comments. And this is probably the 4th time I've tried to end this video. So we're going to end here. Thank you so much for watching. Just to further show the craziness as I continue to try and hunt down this problem, I have gotten it better. I've cleaned this area a million more times. I have lifted the cap out. I've checked it to ground with the 1 meg, confirmed the cap is not leaking any voltage. And it's just so perplexing to me. Now the static is basically gone apart from around this area. So we've dropped it, but I just want to show how crazy this is. So currently, I took the wire, this white wire right here that then is under the board and goes to this eyelet right here. I poke the wire up through so that it is not touching the metal eyelet at all, and then tack solder the cap onto that one lead. And I can show doing the beeping test on the multimeter here, where it's showing if they are connected or not. I can show that they are not connected. This is not touching the eyelet whatsoever, and we're still getting a little bit of voltage here, 0.017, 0.018. Now again, the cap tests perfect. There is no leaking DC voltage off of this cap, already tested. So it's entirely down to, it has to be the wire. That's the only explanation I could possibly have. I've exhausted every other opportunity or every other possibility. The wire and the cap are not touching the eyelet at all. It is floating in between the eyelet. I will show that real quick. Continuity test here. Let me go back to ohm. I don't know if it'll do it actually while there's voltage, but we'll find out. So let's do this real quick. So you can see this is actually beeping. Touch the eyelet, no beep. So it is not touching whatsoever. So again, what that means is that we are seeing this voltage, if I can get to hook on, whoops, I should go to ground. We are seeing about 0.02 volts with literally nothing. The only option it can be is the wire. So the wire itself has to be slightly conductive. There's no other explanation that would explain why just nothing is seeming to work. And yeah, it's incredibly frustrating, but again, there's no other explanation I can think of. So as far as I'm concerned, that's pretty conclusive. Now I'm curious, actually, if I do this, if I try and move it to touch the eyelet, if the actual voltage changes. Let's see. Try and get it to touch. Does not seem like it is. So, okay, we're touching the metal here, and it's not changing. So it's has nothing to do with the eyelet. Eyelet is perfectly fine. The board is perfectly fine around it. It is purely, again, only explanation I can come up with, it is purely the wire itself. So we're not going to go ahead, and be swapping vintage wire for that reason, but maybe this is helpful for somebody down the road, but what an absolute pain in the butt. But with that done, we are, I guess, officially done with this amplifier because that's fairly conclusive to me. The amp is perfectly fine. Otherwise, there's no pops, crackles, nothing. It is dead silent. Again, no static here, just a little bit up top. This one is just a little bit of static right here, but nothing in this range. And we've done everything we can to this eyelet, which I already showed, I believe, in the video. So we are done as far as I'm concerned. Obviously, I will desolder this tack solder. I will connect these wires better to the eyelet, but we're good. What an interesting project this has been. I'm very thankful to have had the opportunity to work on something so special. So shout out to you, Scott. Thanks again for trusting me with it. And I'm excited for you to get it back and hopefully enjoy it for many years to come. But if you guys enjoyed this video and the series in general, give the video a thumbs up. I really appreciate that. Subscribe if you want to follow along with more craziness, I'm sure, coming in the future. And until next time, see you guys. And here we go with the amp all finished. I'm so pleased with how this came out. It looks like I didn't do anything, which means I did a good job. Did exactly what I set out to do. So we'll go through it really quickly here. So we've got the bias circuit with the adjustable bias and a new resistor there. We got a Sprague atom stuffed in the cap, the original cap shell there. We've got a 3-prong with the ground soldered to chassis. Don't mind the death cap, it is disconnected, as is the ground switch here. And the 3-prong is wired to code, how it should be. Moving on over here, we've got the presence control. And so the astron on the presence control is leaky, so that's been replaced with a new old stock blue molded in the correct value. That's working great. Moving on over here, we've got one of the screen resistors right there. So that's been replaced with the new old stock Allen Bradley with the extra ring from it being a military resistor removed. That looks all good. And then every single solder joint on this amplifier I touched. And just to kind of make sure they were flowed cleanly and there's no, hitting cracks or anything. All of the astrons and blue moldeds tested perfectly fine. I lifted them up, did the 1 meg to ground, and no leaky voltage, which is pretty amazing, incredibly rare. And we can see more of the stuff caps here. So you can easily tell from the side. But of course, the money shot is right here, where they look all original. And then of course the doghouse you guys have already seen in an earlier episode. That's all been done with F&T caps. And yeah, that's it. Beautiful.